Alright, welcome back. This is our fourth video in our first unit. The unit is limits. This particular video is about continuity. So let's begin with establishing what continuity is. Continuity is the idea that at x equals some point c, there is no interruption in the graph of f. So ideally, what a continuous function would look like is this. There's no interruption there. You see that it just nice and smoothly moves across, and you can see that even as it passes across C, it's going to be just smoothly going with nothing. No holes, no asymptotes, none of that. I pronounced asymptotes weirdly there, but no asymptotes, none of that. It's just nice and smoothly across C. When you're checking for continuity, you have to check if f of c is defined. Basically, when you look at the graph, is there a y value there? Is there no hole? Is there no asymptote? As long as it's like the function continues through there, there's a point there, you're good there. 2, you have to check that the limit as x approaches c exists. So does the function approach that point? So is the point that the function is at the same the function approaches from the left and from the right side? And the third one is obviously just check if those two values are the same. And then you'll see, oh yeah, well the function is continuous if they're the same. Now these are discontinuities. The second one is the prime example of what I have to check if the limit is the same as the actual value, because the middle one, you can see that the y value actually jumps there, and there's a hole, and the actual value is defined up there, but that's actually not continuous. So the left two images are removable discontinuities, and the right one is a non-removable discontinuity. You can also call it a jump discontinuity for that one, because it jumps from, when you take the limit from the left, it approaches one value, but then when you take it from the right, it approaches a different value, so that it jumps from one y value to another at an instant x equals c value. Now this is how else you can check for continuity. You do one-sided limits. This is how you find what the function is going to be approaching from different sides. So when you have the limit x approaches c, you can have that little plus sign. It looks like the c is raised to that power, but that just means that you're approaching the function from the right side. You're coming from the right side inward, and you're using that to find the limit from the function just from the right side. So even if there's a jump discontinuity, like you see there, it's still going to give you that value because you're only approaching it from one side. And then if you have a c with the minus right there, with the limit right there, you can see that that means that it approaches it from the left side, and you'll get the y value, or what the y value that the function approaches in that case. So this is how you can find the different limits from different sides, and then that's another way you can check if it's continuous, because if you're getting two different y values, that's not continuous. So then this is basically what I just stated. If the limit as x approaches c from the positive is equal to limit x approaches c from the negative, which was not true for the image that we saw in the previous slide, then limit x approaches c of f of x exists. For the previous slide, that limit would not exist, but this is how you would check if it exists for other problems. Thank you.